and gentlemen, welcome to TFI CAD Tips. I'm going to start this tutorial off with a bit of a story, bit of background, a little anecdote as to why I'm doing this tutorial. I might explain to a few people where you would use this and why you would want to do this in the first place, in case that's not clear. So I was in the office earlier on this week, and a guy came over to my desk, called me over to his desk. Nice guy, Hungarian chap, can't pronounce his name, not going to try, I'll embarrass myself. But he was like, Neil, I've got this assembly here. It's been sent to me by a client or a supplier. It wasn't this assembly here. It was a very similar one. It was a machine, but it was similar in size and nature. And he was like, they've sent it as a step. I've opened it up, and it's exploded that step file into hundreds of parts and pieces, and that's fair enough, but I want to stick it into the vault, and it's not going into vault. And I was like, dude, I'm just going to stop you there. Bro, you're not putting that in my vault. You are not putting those 100 and something pieces of crap into my vault. He was like, okay, so what do I do? I was like, well, why are you using this? Why do you have this? What are you going to do with it? And he was like, well, this is the customer's assembly. They've given it to me and they want to see their machine on our factory layout. So I need to put it in my assembly and just show it there. And I was like, all right, fine. That's not a problem. I'll allow you to do that. But you're not putting 100 and something pieces into my vault. Because why do you need 100 and something pieces? Why don't you simplify the assembly down into one part and then just have one part instead of 100 parts? Yeah, that would be better, wouldn't it? It would be. How do I do that? Right, okay. That's where we are. That's where we're at. So we want to take an assembly that has hundreds of parts. We want to simplify it down into one object because we don't need a bill of materials for it. We don't need to have hundreds of parts if they can be represented as one piece instead. And that's one of the reasons that you would use simplification. Where things get a little bit confusing is the different methods that Inventor has for simplifying assemblies. There's at least three. And that's where people get a bit confused because they've heard the word Shrinkwrap being used. Shrinkwrap, that sounds meaningful and purposeful. I want to shrink-wrap something. It sounds like I know what I'm doing. I want to shrink-wrap it. Show me how to shrink-wrap. But someone's mentioned derive. Derive component, derive part. Do I derive or shrink-wrap? What's the difference between derive and shrink-wrap? Oh, my new Inventor has this tab along the top, simplify, and I can create a simplified part. I've heard shrink wrap simplify something. Why would I shrink wrap and then why would I do this one here? So the purpose of this video is to explain what the different simplification methods are, where you would use each one, and the differences between them. The too long didn't read, the TLDR of it all, is they all kind of do the same thing. Emphasis on the word kinda. The end result is the same. You're taking an assembly, and after you've done either three options, you're ending up with a single part, an IPT, which looks like the assembly, but it's a part. So you end up with the same result, but there's three different ways of getting there. That's in a nutshell, that's it. So what we're going to do is we're going to look at the three different options and explain what they are. So we'll start with shrink wrap, right? We'll start with a shrink wrap. So with shrink wrap, the whole point, well, not the whole point, but the main purpose of shrink wrap originally, when it was first introduced into Inventor, around about 2012-ish, might be 2000. Who cares? Doesn't matter. It's not important. One of the original purpose of shrink wrap was sending out your assemblies to somebody else, not receiving them and using them, but sending them out. I want to send some. Say this is our assembly, right? We designed this unit here, and we want to send this to a client or a supplier, and we want them to. They just need to use it in their assemblies, but we don't want to give them our IP, right? We don't want to give them our intellectual property. We don't want them to be able to reverse engineer it. So we shrink wrap it down into a part and we remove detail whilst we're doing it. That's the point of shrink wrap. So you're still going to end up with a single IPT, but you're going to remove some detail from it as you're doing it. How do you shrink wrap? Well, there's a number of different ways of doing it. One of the most common way and the easiest way of doing that is to, when you've got the assembly open, you go to the component drop down and you select the shrink wrap option. There is a drop down here which has shrink wrap substitute in it, but we're not going to use that one, right? We're just going to stick with a straightforward shrink wrap. Because we're going to be making a new part, we're going to funnel this assembly into an IPT. It's going to create a physical IPT part. So we need to give that a name. So call this something that you recognize and that the recipient will recognize. So my product simplified, something like that will do. The template, you can leave that as a standard IPT, and then for the location, just drop it somewhere where you're going to be finding it later on, somewhere easy to find, so your desktop, something like that. Click save, and then for the bomb structure, it's not that important, but if if you know that the recipient uses Inventor and they're going to be sticking this in their assemblies, you might want to set it as reference so it's not included in their bill of materials. And it's just that extra thing. It's just that extra step. You know what you're doing. You've set it as reference. You've been courteous. I know you don't want this to be in your BOM, so I'm going to set it as reference. I'm going to take that work away from you because I'm a champ, and they'll be appreciative of that if they know what they're doing. And then click OK. That then opens up the Shrinkwrap dialog box, right? You get a different set of options in the Shrinkwrap dialog box than as if you were to go to the other options, right? But essentially, we're heading towards the same goal, making an IPT. So the first set of options along the top, you get the style. The style matters. By default, and the most common option is the option on the right-hand side, which is a single composite feature. The IPT will be a surface model of the original assembly. That just means it's more lightweight. A surface is a thin-walled structure. It's a thin-walled object. It doesn't have any mass. It doesn't have any internal mass. It just makes it lightweight. It's what you're doing here. You're turning an assembly into a part. You're converting, you're cramming hundreds of parts into one. So you want to make it as lightweight as possible. And a surface model is the best way of going about doing that. If you want to go for the other options, you can say make it a solid body and then make sure you keep the seams between the faces if you want to see, gaps and edges and stuff between parts. It'll look the same. It will look the same. Even if you go for a surface, it'll still keep the textures and the colours and the appearances. So it doesn't really matter, but the best option is to keep it with a surface. Right, the simplification options, right? This is where things start to fall apart a little bit because it's not the best. It's not the best. If you want to make sure that you're retaining as much IP as possible and you're not giving them more information than they need to see, you can start to simplify it by removing geometry by visibility, which is not the best explanation of what this does. Removing geometry by visibility removes objects based on what you can see from the outside. Right? That's the most simplest way I can explain this. However, what happens is something completely different. It just seems to be random. So, and the only option you've got as well is this slide bar. You just slide it up and you're basing it on a percentage value, which means nothing to nobody. So remove 35% of parts and faces by visibility is essentially what's going on here. Then you click preview and it'll do its thing. Right, and before I do that, I'm going to undo hole patching because we only want to see the results of this. We'll get rid of that, and then click preview. So it's removing 35% of parts by visibility, or parts and faces by visibility, and then that happens. And you're like, that's not the desired effect. I wanted to keep this. How do I select this to keep this? Well, you can't. Unfortunately, you can't. You just have to remove. You have to just drag the slide bar down, hit preview until it starts adding bits again. And you're like, can I get away with this? Possibly. I could possibly get away with that, but now I've got a bar here floating in space. That's not brilliant. That's not great. This is no good to me at all. So let's select whole parts only and click preview. See if that makes a difference. Well, it does a little bit, but there's still things sort of floating off here. Can I get away with that? Possibly. You can see what I mean. We've now randomly got a component missing here. So it's not the... And look at that. The monitor is now floating. One of the hinges is just... One of the arm lengths has gone off. It's not brilliant at all. So you can maybe untick that. Don't do that. Let's bring everything back on. So everything's back. Let's remove parts by size. And then the size ratio is, again, just a percentage. So what it does is, essentially, it puts a big box around the entire assembly. And based on the size of that entire bounding box, it'll remove parts that are, say, 30% and below the size of that overall bounding box. Let's hit preview. And you end up with this. And you're like, no, that's no good to me at all. That is no good. So you can drop this down to maybe 10% and preview. And it's still not the best. You see what I mean? So Shrinkwrap isn't the best. If you're not bothered about IP, you can just keep everything on, and hopefully the part file that you end up with isn't going to be too big. Right, hole patching. This is something you could maybe use. Right, hole patching will put a surface and blank up any gaps and holes that are in your model, and that doesn't just mean circles. It's not just drilled holes. It means anything. So, like for example, this box here. This lip that runs along the top of the box, that's classed as a hole. So if we say patch up all the holes, it'll patch up the top of the box. It'll patch up these circles here. It'll blank any faces that it sees. It works quite well, actually. It works quite well. So that might be the best option that you've got for retaining intellectual property. So we'll keep with that. We'll patch up all the holes, right? Include other objects, right? You might want to include work geometry, some sketches that you've got in there. In most cases, you don't. You just want to untick all of these options here. You want to go for reduced memory mode. That means that if we remember the original assembly, it had a browser tree. You could see all the parts. Do you want people to see the browser nodes from the original assembly? Well, if you don't, select reduce memory mode. There's just less detail in the part file. Remove all internal voids. So what it'll try and do is, so we've patched up the holes. If you wanted to sort of fill that area as well, you can ask it to do that. The result's going to be completely different based on what assembly you've got and whether you've got any voids, how big they are, if there's anything in those voids. So you can trial and error that. You can do it once with it ticked, you can do it again with it unticked and see what the difference is, and then make a decision based on that. Break link. Right, this one's quite important. It is important, but you can change your mind later. If you select break link, there'll be no link between the original assembly and the part you've made. If you don't break the link, what can happen is if your original assembly changes, so you might add some new parts in, you might move some of the legs around, make them increased height, well, your shrink wrap part will update. You might want that to happen, you might not. If you've sent it to the client, well, it doesn't matter because it's not going to be able to update, is it? Because it's over on a client site. So in most cases, you probably do want to break the link. Click OK, and then what it's going to do is now funnel all of those assembly parts, blends them down, shrink wraps them into a single part file. And then the result, well, it's anyone's guess. I haven't done this yet. I haven't practiced this at all, as you can probably tell, because I'm just trying to fill time. I'm just gabbing. I'm ad-libbing I think that's the proper word, isn't it? I'm ad-libbing, filling in time with waffle before the there we go, we now have it done. So this is the IPT finished, and I would say as far as IP goes, we've filled in some holes, we've blanked some plates, and we've now ended up with a single part that can't be reverse engineered because it doesn't have a browser tree. Because we've selected reduce memory mode and broke the link, there's no tree structure here, so the recipient can't see what contributes towards this assembly. So what you would then do is save this. That saves it to my desktop, and we've now got a shrink-wrapped, simplified, single part representation of the assembly. The IPT itself is going to be quite large though, so there it is. It's 24 meg IPT, which it's not that bad actually. On most systems, that should cope with it. That should be fine. And that is shrink wrap. That's it. Does that make sense? I hope so. Because it's relatively simple. So that's what shrink wrap does. You can then send that off to a client, and then they have your assembly, and they can use it if they want. Right, that's the first option. Right, the second option is Derive. Right, Derive gives you a few more options. Right, let's shut this down, and let's shut that down, and then let's start a new IPT. Right, so Derive Component or Derive Part, Derive Assembly works the complete opposite way around to shrink wrap. You start with an empty part file, and then you're pulling the assembly into the part. So you work on the other way around. So to do this, you go to the Manage tab, and then you select Derive. You browse to your assembly. We'll stick with the same one for consistency, and then we'll click Open. Read. The Derive command gives you more flexibility for excluding components than shrink wrap, but you need to be a little bit careful, because if your original assembly has any view reps, any assembly view representations set, that can restrict what you can do. So the best option is to go to the representation tab, and if it's set to default, the default view rep is locked. Right? If you're telling Inventor, I want to derive the default locked design view into a part file, it's not going to let you exclude any of the parts. So what you need to do is either make a new view rep that's unlocked or use an existing one. So you can see we've got one here called screen. Well, I don't know what's in the representation screen, so we can cancel this. Right, we'll cancel this. We'll do this properly, and then we'll reopen the assembly. We'll reopen the test station. We'll go to representations, view. Notice how the default view rep is locked. It's got a little padlock next to it. It's not much use to me. So we can create a new view rep, and then we will call this we'll call this Derive. Or we'll just call it for Derived. Right? We'll just call it for Derived, so we know exactly what it is. And that includes all the components. Everything's visible. So we'll save this, and then we'll shut it down. We'll go back to our part, and then we'll re-derive. So we'll go back to Derive, pick the test station, And then on the representation tab, we'll make sure for Derive is selected. Now, there's a ticky box here, which means that the derived part is associatively linked to the view rep. Do we want that? Well, it depends on your use case, doesn't it? If you're deriving this part so that it always looks the same as the original assembly, then you want that ticked. But then that's going to stop you from excluding the parts, because if you're excluding the parts, then it's not going to look the same, is it? So you might want to untick this so it isn't associatively linked to the original assembly. Then you can come into the component selection bit, and you can say, right, well, I'm giving this to a client. So I don't want them to see these two electrical boxes here. So that's these two pieces here. I can then click the little yellow circle, and that turns into a grey little slash, which if you look up here, hover over the grey slash, it excludes the selected component. So I want to exclude that. These boxes here, that's these things here. Well, I don't want them to have that, and that. All they really need is they just need the frame. They need the frame and the bits on top. I'm saying the bits on top because I can't be bothered to exclude everything, but they just need those. And then we can make sure this comes in as a surface, just like the shrink wrap. We can say, well, we want to make this into a surface. And then that's pretty much it. The rest of them, if you want to, like for example, the monitor screen, if you didn't want them to see the actual monitor screen, you can ask Inventor to convert it into a bounding box. So you'd click the little yellow circle until it turns into a bounding box. Now, I don't know which one of these parts that it are. Right. So we would have to then drill down into the tree structure, find that, and then convert that into a box. And it will convert the monitor screen into just a green box. You might not want to do that. You might want to do that. It's entirely use case dependent, isn't it, really? All right, then. So that's excluding parts, and that's converting parts into bounding boxes, right? There's a couple of other options there, but that's the main things you'd want to do. If you go to Other, well, this is where you can start including parameters and different bits and pieces, work planes and sketches and stuff, but by default, it just excludes everything. I don't need any of that rubbish. Everything's excluded. The representations, well, we start from the derived design view. We've went over that. We're fine with that. If you had certain positional representations, you might be deriving a crane, which has got an up and a down position. You might want to derive the down position, for example, so you could pick that here. Options. Well, this is where it gives you some of the shrink wrap options, but if you were going to use those, you'd just use shrink wrap, wouldn't you? So we'll not go here. We'll not use any of these, but you can also patch holes if you want to. By default, all the options are deselected. If you want to patch the holes, you can say, well, yeah, let's patch the holes whilst we're doing it. And that just gives us that little extra level of safety. So we'll patch those holes. Scale factor, right? You don't get this option with shrink wrap. That's what I'm saying. We're doing the same thing. You get the same end result, but you get a few more options, a few different options based on which method you go with. So Derive Assembly lets you scale the model up or down. Now, this is quite handy when people get given assemblies which are in a different unit set. So you might be given something that was modeled in inches, but you want it in millimeters. So you can maybe scale it up by 25.4 and it'll change the scale factor. Or you can maybe just say, well, it's a little bit too big. I want to scale it down by 0.1 and you'll get a smaller IPT. Or if you have no interest whatsoever in changing the scale factor, you can just leave it as 1. Mirrored assembly. This is another good option. You might be wanting to create a left and a right hand part. So you might be, say, an aeroplane wing. You've modelled the entire right wing. You wanted the exact same thing for the left-hand side. Well, you can derive that right assembly into the left-hand side and select mirror. And I want to mirror it across a certain, use your planes as centre lines. Boosh. So you can do that. You can mirror it as you're deriving it. Use the color override from the source component. Well, yes, as long as you don't have any need to change the colors and the textures on the derived part, just leave this ticked, and it will use the original colors and textures from the original assembly in the part you're making. Reduce memory mode. We've been over that. We want that ticked, and then remove all internal voids. Well, we've seen that as well. And then you click OK, and then what it does is it funnels that assembly into this part, very similar in the way Shrinkwrap worked, but we're going the other way around. We've given it a few extra commands. We've given it a few extra instructions. Take away those boxes at the bottom. Get rid of these electrical components here, and then blank up this monitor face here, and we end up with that, looking tasty and crispy creamy. And then you would say save that to the desktop, and then this is going to be the derived version of my product. Save that. Yes, I know it's not in the assembly, it's not in the project, and then that's it done. Right, in terms of file size, this one is, it's that one there. I don't know what the size is. Let's have a look. It's going to pop off there. And it's only 9 megabytes. That's a lot smaller. But that's because it's got less detail and it doesn't have these boxes in. So yeah, that's a better version of it. Exactly the same thing. It's still an IPT. It's still simplified down from the same assembly, but we just got to the end result in a different way. Now, there's another use case for Derive Part, right? This isn't the only way or the only reason why you'd use Derive Part. Another way is sort of like skeletal modeling, almost, but not really. You might have an assembly which is going to be the start point of a new design. It's going to be, you might have like a base plate which you've modeled up, and you want that base plate to be the start of all your future parts. Well, what you can do is you can say, right, I want to start a new IPT, and then the start point, I want this block to be a start point, and I've already modeled it. So what you would do is you go to manage, you go to derive, and you'd say, right, well, you say, let's pick something random that we can use. That looks a bit too ugly. This thing here, right? This is going to be the start point of a new design. So you can derive that part into this part, and it just drops it in, and you can just say, okay, fine, everything's tickety-boo, and that is now the start point of a new design. You can now start sketching stuff on it. You can say, I want to sketch here, I want to create new geometry off here, and that's now the start point of every new model. And if you decide, well, okay, well, there's going to be a revision to this original start point, you can go to the original model, change, I don't know, cut a hole through it, increase the length of this thread, and then anything that you've created and derived this into will update. That's another use of Derive Part. Very useful, actually. It's really, really useful if you've got a need to do that. So that's another reason you'd use Derive Part. Right, the final. Oh, God, this is a long video. I know. If you've stuck with me this long, well done. Because I don't script these videos at all, right? I literally just start them up and I just waffle. I have no idea if I'm making any sense or whether this is actually good information. I have no idea, right? But the third option is the most recent one. It's the simplify one. This does exactly the same thing as Shrinkwrap and Derive Part, right? It does exactly the same thing, but it's more user-friendly, right? It's more newbie-friendly. What it allows you to do is just say, I want to make a simplified part, right? You just click it. It gives you the same box as Shrinkwrap and Derive Part. We're making a new IPT, right? And this is going to be the simplified part using the ribbon tab. And we'll save this to the desktop as well, alongside the other two. Yes. And then you just click OK, and that is it. It just derives the entire assembly into a part file. No options, no messing about, no ticky boxes, no circles, no nothing. It just does it. And it's newbie friendly. Doesn't give you any options. And I'm still filling time. I'm thinking, when's this green bar going to reach the end, and just do it? But that's what it does. That's what it does. It just skips all the crap. It skips all the junk. You're not interested in all these ticky boxes, all these options. I just want to convert my assembly into a part file. Don't hassle me with any nonsense. Just go and do it, and it'll do it. The problem with this option is that it's going to result in the largest assembly because it doesn't give you the option to convert it into a surface. It's only giving you the option of picking solid models. So it's going to be larger than the other two, and it's going to have more detail in it than the other two, which is, in some cases, that might be fine. You might not care, but there it is. Click Save, and that's it done. So you get the same browser tree, you get the same node. So this little node here is a link back to the original assembly. Exactly the same node as you get with Derive Part and Shrinkwrap. So if we expand that, because we didn't get the option of reduced memory mode, we get all the nodes in here. If you right click on the node, you get the same options as you do in the other two. You can edit the derived assembly. So if you think, oh shit, well actually I do want to change some stuff, well you now get the option because you can edit it and start excluding stuff. You can break the link as well. If you right click on that node, I didn't show you this in the other two examples because I was intentionally leaving it until the end, but if you do retain a link between the original assembly and the part that you've created, you can break that link afterwards. I would always recommend that you suppress the link because I've lost count of the amount of times people have broken the link and then they've went, shit, I need that link back, I need to update it. Well, you can't, you've broken it, it can't be done. If you suppress it, it severs the link temporarily and you can re-enable it later on. It's always the best option, unless you are sending it out to a client. Right, so that's the simplified option. Now, if we go to the desktop and look at the file size of this one, which is using the ribbon tab, this one is 36 megabytes in size. So it's much bigger than the other two, 36, 24, and 9 megabytes in size. So this option gives you the simplest way of doing it, but it's the largest file size and with the less options during transit. Right. The other option that you've got as well is you can play around with this a little bit. Right. You've got two other options here. Include components. Right. What this will do, this will allow you to manually select the objects in the assembly that you want to simplify. Right. But you have to do that before you do this bit. So you say, right, I want to include components. I want to create a simplified assembly of this, maybe these bits here, the top of the bench, that there and that there. I want the uprights, and then I want the cross members. Right, just give me an assembly with those in, please. That's all I want. So you pick those, right click and OK. What it does is it creates a view rep with just those bits in that you clicked, and then you just click simplified part. Let's just call this less parts. Drop it on the desktop again. Save it there. Yes, I know you've mentioned, and then click OK. And then you get a much smaller assembly with just those bits in that you ticked. And that's it. We go to the desktop again. We haven't saved it yet, have we? No, we need to save it first. Okay, and then open, and then there it is. And then this one will be even smaller again. This one should only be a couple of meg max. Yep, 2 meg, 1.92. So that's what Simplify does. It's exactly the same thing as Shrinkwrap and Derive, but it just gets there in a different way. It's more user-friendly. Include the bits that I want to simplify, then simplify it. Now, the third option here, which is define envelopes, well, we've seen that in action in Derive Part. This allows you to pick some bits, and it will convert them into a bounding box. So it just converts them into a solid. So maybe you do want to simplify these models as you're pushing them into other programs. You might be sending these assemblies over to something like Revit. And Revit doesn't need to see all the grooves and all the profiles of all the frames. Revit just needs to know that there's something there. Well, you can simplify them down into enveloped pieces and then simplify it. And then click Test Station Simplified. Come on. Simplify. The screen's quite far away. Right, there we go. And then we can put that on the desktop. So this is the same as the other one, but the uprights are simplified down into boxes. And OK, and then that creates us the assembly with the parts uprights as bounding boxes. And there we go. And you can then go to your desktop, and then you can say, right, well, I haven't saved it again, have I? Right, save it. OK, and then you can go to your desktop, pick up that one there, which I don't know if it's going to be smaller again. I'm imagining around about the same size. Oh no, it's smaller again, 1.65 megabytes. And then you can take that and then send it in an email, or you'll send it to an email, or do whatever you want to it. Put it on a network drive, give it to somebody else, and that's your assembly simplified again. Alright, if you've made it to the end of this, I genuinely commend you. I bow before you with respect and admiration, because honestly my lips are numb from talking so much. But I think I've covered all the simplification options, where you would use them, why you'd use them, and what the different benefits are to the different simplification methods. Hopefully it made sense. If it didn't, let me know in the comments, and I can either redo this with a bit more structure, because this is just typical TFI. It's like, well, I know what I want to do. I'll just open up Inventor and I'll just do it. But hopefully it made sense. If it did, press like on the video. If you haven't subscribed already, do subscribe. Obviously more of these type of things coming in the future, as I think them up and as issues happen in the office. It gives me ideas for videos and stuff. And yeah, thanks very much, and I'll see you later on. Toodles.